Hi everyone, my name is Babisha, and in this lecture we will learn about LSA, LSTB, autonomous system, as well as about area. But before going deep into it, let's understand what was happening in RIP and why we chose OSPF, right? For that, let's understand RIP. Okay, so what was happening in RIP? Let's suppose we have router 1 connected to our router 2, then connected to router 3, let's suppose. So if I talk about the advertisement that was happening or the routing that was happening, what it was based on. So let's suppose R1 has information about any network connected to it. It sends that information to R2 and then R2 sends that information to R3. So the connection between R1 and R3 is not direct. It is through R2, right? So this type of routing is known as routing by oh routing by rumor. Right, and this is not reliable. So this was the first limitation that it was based on routing by rumor. Right, Chinese whisper, you can say. Now the second one. The second thing is, if you look at the metric of the RIP, so it was hop count, right? And the maximum limit of the hop count was 15, right? 15 was the limit. As it hits to 16, we call it infinity or unreachable. So by this, we cannot scale it in a larger network, right? Scalability is the issue. So this was the second issue why we can't use RIP anymore. If I talk about the third one, if I talk about the third one, so third one is that let's suppose we have router 1 connected to router 2. Then let's suppose we have router 3, router 4, and then router 5, let's suppose. So there are two ways. The very first is this way, and this is connected with 10 gigahertz, 10 giga, and this is connected with 1 gig and 1 gig. So this is much more faster, right? But if you look at it that we are using RIP, right, and it works on the hop count, and we want to reach from R1, we want to reach to R5. So by default, it will choose this path, which is slower if you go through the bandwidth thing, 1 gigahertz, right? But if we choose this, the one with two hop count, I guess three, 1, 2, 3, yes, three hop counts. So this basically will be the faster one, but it will neglect it. So this is also an drawback of RRIP. So this is the reason why we chose OSPF. Now, when we talk about OSPF, how it works. OSPF. So OSPF, the working of OSPF is, let's suppose this is router 1. Let's suppose this is router 2. And let's suppose this is router 3. Let's connect this. Great. Now, our router 1 will create an LSA, that is link state advertisement of R1. Also, R2 will create its own LSA, and similarly, R3 will also create its LSA. Now, R1, R2, R3 after creating their LSAs, they will store that LSA in their own LSDBs, that is link state database. Similarly, R2 will also and R3 will also save it in their own LSDBs. R2 save and R3 LSA. After synchronization will happen, what they will do is they will store each other's LSA. So R2's LSA will be there in the router one's LSDB. Similarly, R3's LSA will be also there. And similarly with this also, it will store. And with this one also, R2's LSA and R1's LSA. Now what will happen after they will store each other's LSA after synchronization? As we have learned that in LSDBs, they use that algorithm. What was that algorithm? Shortest path first algorithm on LSDBs, right? To find the best shortest path, right? After, as an input, when they will get this shortest path across the networks, they will populate that in their own routing table, right? This is what was happening. So here we have configured. So here we have learned two concepts, right? The very first was LSA, that is link state advertisement, and the second one was LSDB, that is link state database. And also we covered this algorithm, that is shortest path first algo, right? After this, let us understand what is autonomous system. So let's take an example of your university's network, your university's network. So here your university will be an autonomous system. Let's suppose this big thing is your university. Now you will not use the whole network, right? You have to make subdivisions of it, right, to run that network, or else it will get overwhelmed and we won't be able to use that. For, let's suppose, our library, we will use this area. For our canteen, let's suppose we'll use this. For our, you know, lab, we will use this, and similarly for our classrooms, we will use this type. So this is an autonomous system, and this is the areas that we have given it. Now, when we talk about computer networks, and when we talk about the OSPF autonomous system, so this is our autonomous system, and we make multiple areas in it to operate. The most important one is area 0. This is known as the backbone area. This is very important, the area 0, right? After that, we can make, like area 1, area 2, and so on. But this one is the most important one. The minimum requirement to operate in an autonomous system is that you have to make the backbone area, or you can say area 0, right? Now also there is one thing with areas, that, as I've told you, area 0 is known as backbone area. What will be the other one called then? It is called as non-backbone area. non-backbone area. This is known as backbone area, and the other one is called non-backbone area. Now, if I want to revise of what we have learned, that is, wait, we'll quickly recap it. We have a router, it generates its own LSA, and that LSA goes into its own LSDB, right? Now, on that LSDB, the algorithm of shortest path first is applied. As the output, whatever the best network, whatever the best path that we gain from across the network, we save that in our routing tables, right? So this was it, and this is our autonomous system, and there we have area 0, the most important one, which is known as backbone area, and the other ones are called non-backbone area. So this was it for this lecture. I hope you enjoyed. See you in the next one.